Yes, class. Good evening. Yes, Zaid, what deleted portions were you mentioning?
And motional electromotive force, then energy conservation, quantitative study, then eddy current is also not there. Yes, ma'am.
Okay, Eddy Currents has also been deleted. Eddy Current was there till the last year. It was there. Eddy Current has been deleted. You sure know about this?
Yes, ma'am, sure.
So let's just quickly have a look on Eddy Currents because just for your knowledge, not from the board exam perspective. Let's just have it, and we'll move on to induction. If C class, if these topics which he was mentioning have been deleted, so induction becomes the very most important topic. So there's a lot of chance that this year questions from induction will come, because eddy current, there was a good theoretical question from Lenz law and eddy current that used to come. So eddy current wasn't difficult topic. Even students who could rote learn it were able to do it, but questions used to come. So if all these have been deleted, then induction becomes a very important topic. Now see, eddy currents are what? Eddy currents are basically currents which are induced. These are induced current. Now you don't have to do all the experiments and everything. You just have to remember what are eddy currents. So currents can be induced not only in conducting coils but also in conducting sheets and blocks. So just a quick revision on eddy currents. So current can be induced in what? In sheets as well as or in these blocks. Right? Now what happens whenever the magnetic flux linked with a sheet or a block changes, then what happens? As soon as the EMF changes, there is induced EMF. As the flux changes, EMF is induced. So induced currents flow in closed path in planes paper perpendicular to the lines of force throughout the body. They look like whirlpools. For example, if these are two magnets which are connected and this is a metal sheet. So this is how the current flows. So this is known as a whirlpool or eddies. So that's why the current, we call it as eddy current or whirlpool current. Also, they are also called as Foucault currents. These are known as eddies or whirlpools. These are known as eddies or whirlpools, and they were also called as the Foucault current. This was based on the scientist's name, I think. His name was Foucault only. I don't remember the full name, but Foucault, I remember it was this Foucault. And in I think some 18s, he discovered this eddy current. He didn't discover it. These were first discovered by him. Then later on, because of the name eddy, because of the whirlpool thing, they were named as eddy current. So this was one thing that you have to keep in mind. Just keep it in mind. Now you don't have to write down anything about it, so it's okay. And just remember one more thing in it: the application part. In induction furnace, eddy current is used. So I'm not making you write the whole stanza or paragraphs on it because just understand it. So what happened if a metal specimen that was placed in a rapid changing magnetic field? So large eddy currents could be experienced because of the high frequency. Then electromagnetic damping is there. Electromagnetic damping. Electromagnetic damping is there. So in that, what happens whenever a current passes through galvanometer? So coil suffers oscillations before it came to rest to the final position. So as the coil moved through the magnetic field, induced current developed. Because of the induced current, there was oscillations in the coil, and those oscillations were damped oscillation. Remember, you must have done in your class 11th damping, damped oscillation, undamped oscillation, and all those. So from here we have electromagnetic damping. Then eddy currents are used in the application of electric brakes, and also in speedometers they are used. And these are some applications. In case of electric brake also, strong magnetic field is there, which changes. So eddy currents are stress set up in the drum, then it exerts a torque, and then the trains or the vehicles get stopped. And speedometers also, speedometer is what magnetic rotators in the for the measuring of speed of the vehicle. So magnet is placed inside it. So as it moves, magnetic field keeps on changing, and eddy current is also developed there. So these are certain applications. Do one thing. First note down these, then we'll start with induction. You people had your class. You people only had your class among these who are present right now today, because half an hour late our class got started, no? So were you people having class or some other batch? Did you people have any class before this today?
No, I don't
No,
think.
not you people, no? All right. All right, last now induction. So induction are also of two types. You have self-induction, you have mutual induction. Now let's study what is meant by induction. So in exam, how the question comes in your board exam, the question is usually what is meant by self-induction, define self-inductance, give its units and dimensions. So all that question we'll do it, means you will be able to do it today. Now let's start with the phenomena of self-induction. This is the phenomena of self-induction. Now see, in case of self-induction, what happens? When a current flows in a coil, it gives rise to magnetic flux through the coil itself. So as the strength of this current changes, suppose you increase the current or decrease the current, what happens? Linked magnetic flux also changes and the opposing EMF is induced in this coil. And EMF is induced in this coil. So this induced EMF, which is present because of the change in flux, because of changing the intensity of the current, we call this EMF as back EMF. It has other names like self-induced EMF. And this whole phenomena is known as self-induction. So self-induction is what? Let me write the proper definition of it. This is just for your explanation. So self-induction is a phenomena. Self-induction is a phenomena self-induction is a phenomena of production of what? What has been produced right now? Of production of this induced EMF only. So it's the production of induced EMF in a coil. Whenever changing current passes through. EMF is induced because of this current only. That's why it is self-induction, because it is happening in a single coil within itself. This single coil is inducing EMF. Current is changing in this coil only. This is a coil. Current is changing in this coil and EMF is also induced in this coil. So that's why this is self-induction. You don't need another coil for induction. Induction means what? Inducing EMF. This time induction here, this means inducing the EMF. So EMF is induced because of the change in current. So self-induction is a phenomenon of production of induced EMF in a coil when changing current. When changing current passes through it. This is what is known as the phenomenon of induced current. Now see, induced current can be understood, not induced current, is a phenomenon of self-induction. It can be understood through certain experiments also. These experiments are not included in NCERT, but just for your knowledge, or if sometimes if required in your answers, you can add on these experiments. There is no harm to add these. Let's say, let me try first. This is a circuit given. This is a battery. Here a switch is there. This is what? This is a closing switch. So this shows what? This is a battery over here. A tapping switch is there, which is connected in series with the coil. This is the coil right now. A number of turns are there. Let's specify it. 1, 2, 3, 4, 5. 5 turns are there. Now let's just take it randomly. Now, as this switch is closed, this is a tapping switch. So as this switch is closed, what happens? Current through this increases. As the switch is closed, current will start flowing. So initially if it was 0, now some amount of current has flown, so current increases. So as current increases from 0 to its maximum value, whatever is the maximum value of this current, what will happen? Induced current will flow in opposite direction of the battery. This will be the direction of induced current. Now, if I say, let's say this was an opening switch, not instead of a closing switch, this is the same circuit that I'm drawing. But here, this is what? This is opening switch. This is an opening switch. So as the tapping switch is opened, the current and the magnetic flux through this coil, what will happen to the magnetic flux? Here also, magnetic flux will also increase. So here what will happen? Current will decrease, magnetic flux will decrease. Both of these quantities get decreased through the coil. And what happened? Induced current flows in the same direction as that, the motion of the flow of original current. So this is one example that which shows self-induction occurs. Self-induction means, see, this was one coil only. In this coil, everything happened. Current increased, flux increased, direction of induced current developed because of induced EMF and everything. Now, these were all the theoretical points and the introduction of self-induction. From here, this definition is important. This definition is asked in the exam to write down. Now, coefficient of self-induction is very easy. So right now, what are we seeing? If current is increasing, flux got increased. If current decreased, then flux got decreased. So what's the relation between current and flux? Are they directly proportional to each other, inversely proportional to each other, independent of each other? What do you people say? Current and flux. Class. They are inversely proportional. Z is inversely proportional. Anyone who has a different answer, or all of you agree with him? No answers means you people agree with him that current and flux have an inverse relation. See, current increased, flux increased. Current decreased, flux decreased. Still now you people will say they have inverse relation. Directly proportional. Yes, Myra Hania, right? They are directly proportional. You're increasing the value of current, flux is increasing. You're decreasing the value of current, flux is decreasing. This shows what? They are directly. So flux is directly proportional to the current. Here we put a constant. Obviously, to remove the proportionality sign, we have to put the constant. And this constant, we call it was what? We call it as coefficient of self-induction. This is known as coefficient of self-induction. Fine. This is known as coefficient of self-induction. Now here in the formula that we use for EMF, the formula that we use for EMF, this was minus d phi over dt. So right now instead of phi, we can put this term. So this becomes what? Minus d Li by dt. Just the value of phi I have kept. So EMF's formula becomes what? Minus L di over dt, because this is a constant. So I can take it out. This becomes the formula of EMF. Now, in your exam, okay, one more thing, how to prove in the exam questions come. So what is the definition of coefficient of self-inductance? This comes this is known as self-inductance also. Instead of writing it as coefficient of self-induction, yes, self-inductance. This is written as self-inductance. You can just use it as self-inductance. L will be used in AC also. It will be used. You will be having LCR circuits and everything. So resistor will be involved. The capacitor that you have studied in chapter 2 will be involved, and the inductor that you have studied, it will be involved. So whatever circuits you have studied, many of the circuits now have been deleted from your syllabus. Earlier there were all the circuits written, all the RC circuits, LR circuits. Right now you don't have every circuit, some of the circuits are there. Now how will you define it? If you put current as 1 amperes, then flux will be equal to the L, self-inductance. So this definition, self-inductance, it is numerically equal to the magnetic flux. This is how you can define it. So the self-inductance is what? This is equal to, numerically equal to the magnetic flux. But when a unit current flows, when a unit current flows through, fine, this is the definition of self-inductance. From here, I think if theoretical questions come, then these are enough. All the LCR circuits are not included now. There were different circuits. Major circuits that are there, they are included. But some of the circuits were there, which had very high integrations and differentiation, not the basic ones. So that have been deleted. So that is not even included in this year. That wasn't included last year or before that year also. I think last it came in 2019. In the paper of 2019 also it did come, but it was there in the syllabus. Some of the circuits that you need not do. Students who prepare for entrances, especially in the classes of entrances, they have those topics still there. Major circuits you have. But yeah, Zed, just go through the syllabus because you are always updated about the syllabus. So just help me with that. Now, from the theoretical perspective, no, definition of self-induction can come, which I have written. Coefficient of self-induction can come, and definition of coefficient of self-induction means self-inductance. The formula phi is equal to Li and E is equal to minus L di over dt can come. Apart from this, units and dimension can be asked. So units will be what? Unit, this L can be written as E divided by di over dt. So this is written as volt, this is ampere per second, this is called as Henry. This is known as 1 Henry. So Henry is the SI unit. And dimensions also are asked. Units and dimensions usually come together, otherwise units is important. Dimensions are least asked in the board exam because this becomes a part of the 11th syllabus. No, that's a, but this can come. This has come in the exam. So if you want, you can write down the whole proper thing. Using this, you can calculate phi divided by I, and phi you can write it as BA divided by I. Magnetic field, you know, area, you know. So when you will solve this, I'm writing it directly. If you want me, I can show you the calculation as well. This is the dimension. Fine, so this is the phenomenon of self-induction. Questions maximum, theoretical basic questions are easy. They come like this. We'll solve numericals, but before that, just note down all these things. L from here it will be E is equal to E dt by di. E is equal to dt by di. Di by dt completely will go in the denominator. So it will be E divided by di over dt. So I think that you have tried to write, no? Minus E by di over dt, no? So di by dt you are saying it's in the denominator. So that's right. Yes, right. Yes, yes, right. There's one more unit Weber per ampere because flux SI unit is what? Flux SI unit is Weber also. So Weber by ampere can also be written. But the most commonly used one is Henry. Otherwise, Weber per ampere is also perfect. What was the formula of magnetic field for a solenoid? Write down all of you in the chat box. Magnetic field for a long solenoid. What was it? That is the formula of magnetic flux, which you have written Z, dA cos theta. Magnetic field for a long solenoid. Samira, right? Others also write magnetic field for a long solenoid. Yes, right. That Z, that symbol is mu. We call it as mu. Mu.
Okay, mu.
So mu Ni, yes, perfect. Mu not Ni. Right. So magnetic field is what? Magnetic field for a long solenoid is mu not Ni. So who all have it? Hanya, can you tell me what is small n here? You are right. The formula is right. B is equal to mu not Ni. What is small n over here? Can you just tell me?
Is the number of turns.
Number of turns. Just the number of turns? Number of turns per unit length. That's right. This is not only n. Hanya, number of turns, you're right, but per unit length. That's why for toroid, we have n by 2 pi r. Remember? Fine. This was for toroid, n by. Now, as rightly you were mentioning Z, magnetic flux formula, you have already mentioned it was what? It was BA. So magnetic flux is what? This is BA. Putting the value of magnetic field, we have mu naught NIA. Just kept the value of magnetic field. Now, cross-sectional area. Cross-sectional area also let us put. Area will be what? Area will be pi r square. Area of the cross-section. This is the cross-sectional area of solenoid. Cross-sectional area of solenoid. Okay, so this is the cross-sectional area of the solenoid. So phi is mu naught NIA. So phi will here become what? Mu naught NI by r square. Till here we have it. We have the value of phi. So phi is what? Mu naught NIA pi r square till now. Now tell me one thing. Even if it is mu naught NIA, let us just keep it as mu naught NIA only. Even if it is mu naught NIA. This is the flux. This is flux for each turn. If we converted it into this term, N into L, means if we write it, or even if we do not write it, even if we are just keeping it like this, this is the flux linked with the entire solenoid. We have to find out the flux linked with the entire solenoid. This was for a single one. So magnetic flux, see, magnetic flux linked with entire solenoid is what? This will be the magnetic flux that is linked with each turn. With each turn multiplied by the number of turns. So magnetic flux linked with each turn is what? Mu naught NIA. Number of turns will be small n into L. From this formula, that why did I ask you people what was the formula of small n? Because from here number of turns can be written as n into capital N. Now what does the formula become? Mu naught n square LIA. This is the whole formula. But also one more thing, phi is also equal to Li. Using the normal inductance rule that we have studied. So if you equate all of these, L will be equal to what? If you equate both of these, see, Li will be equal to mu naught n square Li into A. current gets cancelled, induction becomes mu naught N square L into A. This is the formula for it. And if you wish to write it in terms of total number of turns, just put N by L here. So that becomes what? If you have to write it in terms of L, that becomes mu naught N square A divided by L. Right? Note down this, then let's do just one or two numericals on self-induction. So from the formula, you can figure out many of the things on which factors does the self-inductance depend on. So obviously self-inductance of a solenoid depends on the geometry, it depends on the magnetic permeability, number of turns also, because number of turns are coming in the numerator, then area of cross-section, these things only. If it comes on what factors L depends. So L depends on what number of turn, it depends on the area, and it depends on the permeability. This can. Yes, if they ask to define 1 Henry, then definition of 1 Henry is that only what I have made you write, 1 volt by 1 ampere per second. So if you just have to write it in terms of words, like self-inductance of a coil is said to be 1 Henry if an induced EMF of 1 volt is set up in it when current in it changes at the rate of 1 ampere per second. So I've made you write now 1 volt by 1 ampere per second. Just write it in terms of words if it asks to define 1 Henry. And please try today's assignment as well. Only Khalid is regular at submitting assignments. What about others? Are you people submitting your assignment on the portal?
Yeah, ma'am.
Submitting, Salman? You submitting?
Yeah. Today's like the recent one also done. Submitted.
Okay, Salman. I'll just check. And please try today's assignment also. There will be good questions from just induction. Please try it. I'll just check Salman yours assignment. And others also. Like, why only Khalid and Salman are active? Salman also used to send it before also. Khalid is also regular with this. Even Samira used to send. Samira, what happened? Are you submitting them?
Yes, ma'am, but I didn't do the recent one.
The recent. Okay, fine. So 1 or 2 assignments here and there, that's fine. Salman, why did you have to take those classes in last year? Last year when you were in 11th. You are very good at submitting assignments. So what happened in 11th? You were not submitting them.
No, that
Okay, because you
like,
are
I didn't pay
always
too much attention. That's why. In 11th.
okay, because you're always answering well. You're getting good scores, and your assignments are also up to date. So yes, I was wondering that why you needed those classes.
And 11th, I wasn't paying attention for formulas, so I will mix them up. That's one reason.
All right. So now your calculations and everything have improved, no?
Yeah, I have kept like a formula book. I have written down.
You have it, no? All right. Then that's very good. If you have the formula book, that is very helpful. When I was in 12th, I used to have a separate notebook for derivations and formula. That helped me a lot in the last one. Because derivations will come no matter what. And they are the lifesavers if you know the formula and derivations for the board exam at least. Let's try this question. 12-volt battery is there, 6 ohm resistor is connected, 10 Henry is the inductance that will flow. If the switch is open, time taken is 1 millisecond, so you have to find out the EMF. Just try, submit your answers, take 2 to 3 minutes. The normal formula that you have of EMF that we have studied right now. So try putting on things, whichever thing is unknown, try to find out it. EMI is also over. You people should give a test of EMI. Just only mutual induction is left. That's a small topic, just like self-induction. That will be over in the next class only. Today I could have completed, but I want to take your derivation tests. So derivation test will be taken today. Not on Monday. Monday is 15th, no? 17th means the next Wednesday, exactly. Do you people agree to give the test? If you do, people, if you all do not have, because your vacations are going on, so I think you people can study EMI. This is a very short lesson, so give a test on EMI on 17th. It's a fresh lesson. You don't even need to study much, and it's a very easy lesson also. Just say yes or no. If anybody has issue, just let me know. Next week, exactly. This is Wednesday today, so next Wednesday. Monday we'll have a regular class. Wednesday after the class, half an hour or 1 hour test on EMFs. I was saying EMI. Zed agrees. What about others?
It's okay. You can take the test next week.
Alright, fine. Have the test next week. I'll inform on the group as well. This test of EMI will be done. Once you are traveling on that day, Hania. So Hania, you can give the test separately, because if your vacation is going, then whenever you say you're available. Okay, Hania, I'll just talk to you. According to your convenience, you're traveling from India, you're going back.
Yes, ma'am.
All right. So, yes, obviously on that date will be difficult because traveling will take a lot of time. So you can give it separately. Just study till 16th, or you can give it on Thursday as well as Friday. Friday also you can give whenever you wish. Just let me know whenever you are available. Whenever you will reach your place, just tell me. Separately you can, the way last test you gave, no, separately you can give this test as well. But just let me know in advance. Other students, 17th August, Wednesday. So once your book one will get over, no, because now very small lessons are left. AC is also a shorter lesson. AC is difficult than EMI, but AC is also a short lesson. EM waves is a very, very easy lesson. And then a little portion from chapter 5th is left, earth magnetism. Then you will be having complete revision of first book. We'll be revising electric fields and everything. So that revision occurs, give the individual tests. See class in this question. A 12-volt battery connected to a 6 ohm resistor. So Voltage is 12 volt, resistance is 6. 10 H is what? 10 Henry is the inductance that is given. So through a switch drives a constant current through the circuit. The switch is suddenly opened if it takes 1 millisecond. So time is given as 1 millisecond, which can be written as 10 to the power minus 3 seconds to open the switch. You have to find out the average EMF. Right now we have studied this equation. Now from here, L is here, L is here. T is here, we don't have current. But from this data, we can easily find out current if you people remember the Ohm's law. So see, class, from here, current can be easily written, current can be easily derived. So current will be voltage divided by resistance, which is 2. So EMF becomes what? Minus 10 into 2 divided by 10 to the power minus 3. Or you can write it as 20. This becomes 3 zeros now. So 20,000. This is the answer. Fine, class. So students, write it down. Just text me done when you have written it. Then we'll take a break of 5 minutes and then we'll start with the test. And please try today's assignment. There will be good questions from. I'll give 2 to 3 questions only. So not only Salman, Khalid and Samaira, others should also submit the assignment. If you people are facing difficulty on the app, then submit it on the WhatsApp. WhatsApp group is also there. From the group, you have my number also. So whatever suits you, just submit. So I'll start the test 5 minutes after. 5 minutes later, I'll start the test. Take a break of 5 minutes. After 5 minutes, just rejoin the class. Just stay connected. You can rejoin the class. So it's 10 o'clock right now. At 10:05, I'll start. So just see what's the time over there. After 5 minutes, just join the class. Yes, class, last 5 minutes left. Yes, class, done with the test. Start submitting your answers. Okay, 5 more minutes, last 5 more minutes, but then submit your answers. Okay, Khalid, you can leave. Allah Hafiz.
Thank you, ma'am. Allah Hafiz.
Yes, class. Now wrap up your answers. Samira, where you have sent it? Learnivio's number, don't send it there. No, Samira. Send it on the group or send it on my number. Don't send it to the Learnivio's number. It becomes difficult to collect your sheet then. Forward it on